Yeah. So this video is regarding nitriding heat treatment process. As per your syllabus, when it comes to diffusion method of heat treatment process, this is the last one. The next, which I'll be discussing, is on selective hardening process. Okay. So let's move on. Nitriding. What happens here is, as usual, the name itself suggests nitriding means you are uh, introducing nitrogen. You're diffusing the nitrogen atoms on the surface of the steel specimen. If you can see this entire setup, the specimen that has to be nitrided, it is kept in the electrical furnace, where that electrical furnace is connected to ammonia gas. Okay, it is an electrical furnace. Okay, so that is maintained at around 500 degrees Celsius. Okay, so at that temperature, what happens when you release the gas, specimen gets heated in this ammonia rich gas. So because of that heat, what happens, nitrogen from the ammonia gets decomposed and tends to diffuse in. The remaining gas is letted out and it is going in the water as like a bubble. Okay, so this is the setup. Okay, this is nitriding. Okay, now if I want to tell you it in the equation form, this is how it happens. At this temperature of around 500 to 580 degrees Celsius, this is the decomposition that takes place, dissociation basically. So ammonia gets dissociated as nitrogen and hydrogen goes away, nitrogen gets diffused. Okay, so this is nitriding process. Next is flame hardening. Okay, till now whatever I discussed, carburizing, nitriding, it was under diffusion method. Okay, if you are still confused, I'll get back to you here. What I discussed so far is carburizing, nitriding, which comes under diffusion method. Now I am discussing regarding selective hardening, under which I am talking about flame hardening process. Okay, so flame hardening. What happens in flame hardening? It's a selective hardening, as I told you. So localized hardening, only the particular part of the surface, not the entire surface, only certain region of the surface is hardened, and that flame hardening means we are using flame for the hardening to happen. Now what flame are we using? It is oxyacetylene flame. Okay, so if you can see here this setup, this is the steel specimen. This part, only this area, okay, to that area, flame, that is oxyacetylene flame, is introduced, and immediately as you pass on, this is a carriage, as you can see, as this pass on, immediately the quenching will be done. What happens? There is rapid cooling, so as a result there will be hardened surface, but only to the localized point. Okay, so that is called as flame hardening, where hardening is done with the use of oxyacetylene flame. Now under that you have three types: spot flame hardening, spin flame hardening, and progressive flame hardening. So under the spot, what happens? Oxyacetylene flame will be directed to the spot that has to be heated and hardened, to the spot. Spin hardening means the workpiece, the specimen, that will be rotated while being in contact with the flame. So your flame is in fixed position and you keep on rotating it. So in a circular way, you are hardening the surface. Progressive flame hardening is the flame as well as the quenching medium is directed across the surface of the steel specimen. It's something which looks like this. Alright, so this is flame hardening process. Okay, typically temperature used in this process is around 850 degrees Celsius. Definitely higher than the critical temperatures. that is 727 degrees Celsius. That is, oxyacetylene flame is at that temperature, and you quench it with the water jet, and the flame hardening process is done. Okay, so this is flame hardening process. In the next video, I'll discuss on induction hardening and age hardening. Okay.